In this lesson out of Classroom Mathematics, we are currently busy with Chapter 12, Geometry of 2D Shapes, and today we will be looking at quadrilaterals. Now, just for an overview of this video, we'll first just look at the simple definitions of the different quadrilaterals, and then we'll look at their individual properties, and then we'll look at a few examples. So, a quadrilateral is a closed four-sided polygon. Then a trapezium is a quadrilateral with a pair of opposite sides parallel. Then a kite is a quadrilateral with both pairs of adjacent sides equal in length. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. A rectangle is a parallelogram with interior angle equal to 90 degrees, and therefore all angles will be equal to 90. Then a rhombus is a parallelogram with all four sides equal to each other. Then we have a square, that's a rectangle with all sides equal in length, or it could be a rhombus with an interior angle equal to 90. So that was the definitions. Next we'll look at the properties. So here we have a trapezium, so the only property that's unique about it is that it has one pair of opposite sides that are parallel. Then we have a kite, so it has two pairs of adjacent sides equal. Then one pair of its opposite angles are also equal. Then the diagonals intersect at 90 degrees. One diagonal bisects the angles, and the long diagonal bisects the short diagonal. Then we have the parallelogram, and the opposite sides are parallel, and the opposite sides are also equal to each other. The opposite angles are equal to each other. The diagonals bisect each other. Then the rectangle, the opposite sides are parallel and equal. All the angles are equal to 90 degrees, and the diagonals are equal and they bisect. Then the rhombus, all sides are equal. The opposite sides are parallel. The opposite angles are equal, and the diagonals bisect at 90 degrees. And then the diagonals bisect the corner angles. Then the square, all the sides are equal. The opposite sides are parallel. All the angles are equal to 90 degrees, and the diagonals are equal and bisect at 90 degrees. And then the diagonals bisect the corner angles. Right, so that was the properties. Now let's look at a few examples. Now example 1 says calculate the lengths of the lines represented by lowercase letters if PQRS is a rhombus with PS equals to 15 units, PR equals to 24 units. Alright, so I start off, I have statement and reason. Now what are we given? We are given PS is 15 units. And we are given that PR, so PR is all of this length, and that's equal to 24 units. Right, so we want to start, let's start with A. So we can immediately see that A is equal to 15 units. And our reason is the sides of a rhombus are equal. Sides of rhombus. Okay, and then to solve for B, so we can see here PS is 24, and I know that PT is equal to TR. So these, because the diagonals of a rhombus bisect each other. So to start off, I'm going to state that PR PR is equal to 24 units because it's given. And then I can say that PT is equal to TR, and that is because the diagonals of a rhombus bisect each other. Okay, and therefore B will be equal to 15, it will be equal to 12 units. Then if we want to solve for C, we have to say that QTP is 90 degrees. That's one of the properties. So QTP is equal to 90 degrees, and that is the diagonals of a rhombus are perpendicular. And then, since we know PT is also going to be 12 units, and we know that A we saw is 15 units, now we have this right angle triangle. So in this triangle, we can then use the theorem of Pythagoras. So we can say that since OP is the long side, I can say that OP squared is equal to the two short sides, or Q2, this is a Q, sorry, yeah, that's QP squared is equal to QT squared plus PT squared. So my reason is theorem of Pythagoras. And then I can substitute in my known values. So we have QP, which is 15 squared, equals to QT, which is C squared, and then plus PT is 12 squared. So to put C on its own, I'm going to take the 12 over, so then 15 squared minus 12 squared is equal to C squared. So C will then be equal to the square root of 15 squared minus 12 squared. So that would be equal to square root of 15 squared minus 12 squared. So this is equal to 9 units. Now for example 2, calculate the sizes of the angles represented by lowercase letters if ABCD is a rectangle. So to start off with, statement, reason. Now, first of all, the only degrees that we're given is this 110 degrees, and we want to solve x and y. All right, so the first thing I'm going to write down is AE, or this AE is equal to EB, because, let's just make that 3 lines, because the diagonals of a rectangle bisect each other. So we have that AE is equal to EB. So what I'm going to do is, because these are equal, these two angles will also be equal to each other. So then I can actually solve for these two angles. And if I have these two angles, I can solve for x because these are complementary angles. So this is then, the reason here is diagonals of rectangle bisect, or equal and bisect. And then I can say that A1, angle A1 will be equal to angle B1. And my reason is equal, or angles opposite equal sides. So angles opposite equal sides. And then I can solve for my angles of a triangle. So A1, angle A1 plus angle B1 plus the 110 degrees will be equal to 180 degrees, and this is angles of a triangle. And then since A1 and is equal to B1, I can replace this B1 with A1. So A1 plus A1 plus 110 degrees equals to 180 degrees. So solving for that, I've got 2A1 equals to 180 degrees minus 110 degrees. So 2A1 is equal to 70 degrees, and A1 is equal to 35 degrees. All right, so now we've established that that's 35. So now to solve for x, I can say that x plus A1, angle A1 is equal to 90 degrees, and my reason is complementary angles, or angles of a rectangle. So therefore I can replace A1's value as 35, so x plus 35 degrees equals to 90 degrees, and x is equal to 90 minus 35 degrees. So that would be equal to 90 minus 35. So that's equal to 55 degrees. Then to find y, since these lines are also parallel, this angle and this angle is alternate angles. So that means that y is equal to 35 degrees, and my reason is alternate angles AB is parallel to DC. And that was the examples. So now you should be able to do exercise 12.3.